Hello everyone, welcome to Coders Camp. So we are today at the 8th day of May LeetCode challenge, and the problem we are going to cover is super palindromes. So the input given here is the two integer values left and right, and we have to return the number of super palindromes within this range left and right, that is inclusive. So let's understand this problem with an example. So here is our given input value where left starts from range 4 and right is up to 1000, and the numbers are set to be super palindromes if they are palindromes and they are squares of another palindromes. For example, from the range 4 to 1000, these are the list of palindromes which are perfect squares. And if you see the numbers, these are squares of these numbers. That is 2 square is 4, 3 square is 9, 11 square is 121, and so on. And if you see 2, 3, 11, 22 are again palindromes. In this case, 22 is a palindrome, and again 484 is a palindrome. So 484 is said to be one super palindrome. But here 26 is not a palindrome, but 676 is a palindrome. So in that case, 26 cannot be considered as a super palindrome. These are the list of super palindromes which has to be considered for our output. So there are four super palindromes within the range 4 to 1000. So that is going to be our output. This seems to be a very easy logic. Like we can iterate from the range starting from left index to right index and take each number and check whether it is a palindrome by passing on to a function is palindrome. So if it returns true, then we are going to check whether its square is a palindrome, that is 4 cross 4 is a palindrome, and again 5 cross 5 is a palindrome, and so on till 999 is a palindrome or not. So if it returns true, then in that case we are going to increment the count and return the result. So this logic seems to be so simple. So if we code it the same way we considered, that is for every possible number, we are checking whether it is palindrome and it is square is palindrome or not. If it returns true, then we are going to update our result and finally return the result. But this solution is time limit exceeded because the range of the string given here is 18. That is, the length of the string is 18, and if we are trying to convert this to number, then the range will become 10 power 18, which is what is making this problem hard. So how are we going to approach this here? As we know, the range of our palindromes are going to be 1 to 10 power 8. We have two options to approach this problem. The first option is check all palindromes and its squares whether they are palindrome or not. If they are, then increment the count and return the result. That is what the solution we have seen, and its time limit exceeded. So how to approach this in an optimized way is create the palindrome ourselves and check whether their squares also palindrome or not. So what is creating palindromes, or how do we create palindromes? So if you consider a string or a number is palindrome, they can either be an even length palindrome or odd length palindrome. So for example, here in this case, any palindrome is going to be repeating its reverse. So 112 is going to be repeated in reverse, that is 112. So we are going to start from the number 1 and append its reverse to form palindrome. For example, 1 1 and 2 2, 3 3, and so on. Same way, if the number is 112 and we are going to create its reverse 211 till some range. Same way, if it is an odd length palindrome, we are going to put a middle number starting from 0 to 9 between. For example, if 1 and 1 is its reverse, then we are going to append a middle number 101, 111, 121, 131, so on to form odd length palindromes. So we are going to construct the strings and its reverse in order to form even and odd length palindromes, and once we form the palindrome within the range, we are going to check whether its square is also a palindrome. In that case, we are going to increment a result and return the result. So here comes the range problem again. Up till what range we need to create this palindrome? So here for our given range, they have said the overall maximum length is going to be 10 power 18. If the squares are going to be in the range 10 power 18, then the actual numbers, that is square root of those numbers, are going to be in the range 10 power 9. So in our problem, we are going to generate these numbers and check its squares are also palindrome. If they are also palindrome, then in that case we are going to increment our result. So if the squares and the actual number are in the range 10 power 9, we are going to generate only half of the numbers and append the reverse. In that case, the number we are going to generate will be of range 10 power 5. So we are going to generate all possible numbers from the range 1 to 10 power 5, and with each number we are going to append its reverse. For example, if it is 1 5, we are going to append its reverse 5 1 to the number. And once the number is generated, it is obviously a palindrome because we are generating it, and we are going to find its square, so that we gonna check whether its square is a palindrome or not. If its square is also a palindrome, then we are going to add that to our result. So hope you understood the solution. Let's go to the code now. So let me get back to the actual code. So yes, as the ranges is in long, we are going to have two variables. Long L is equal to result is going to count the number of super palindromes and finally return the result. So first let us declare a list which is going to hold all the palindromic numbers. So here this list is going to have all created palindromes. So now we are going to add all single digit numbers because each single digit number is an individual palindrome. Now we are going to generate all even and odd length palindromes. For that, we are going to have our range starting from 1 to 10 power 5. Inside that, we are going to have our left part. We converting that number to a string, and right part would be the reverse of that string. So yes, now we have both left as well as right path. So first we are going to add the even length palindromes. For that, I'm going to add in my list left part plus right part. So this will add all possible even length palindromes. Now time to add odd length. For that we are going to iterate through all our digits starting from 0 till 9. So in the same thing, we are going to append our j in between, so that we could generate all odd length palindromes. Now our palindromes are generated within the range 1 to 10 power 5. So now we are going to check its squares. So let us iterate our list, and n is equal to its square. So now n is having the square. We are going to check whether it is within the range, and n is greater than or equal to L, and n is less than or equal to R. And if it is a palindrome, then we are going to iterate our result. So yes, this is it. We have created our palindromes and we are checking whether its square is within the range and it is a palindrome or as well. Then we are going to iterate our result. So we have to write our is palindrome function. Since we are passing this as a string, we are going to have two pointers left and right, and they are going to compare the characters at each end. So yes, this is done. Let's run and try. Let's submit. Yes, the solution is accepted. So thanks for watching the video. If you like the video, hit like, subscribe, and let me know in comments. Thank you.